Good morning to all my dear students. Welcome to the next lecture on the transition elements. We have discussed what are the transition elements, what is its position in the periodic table, how they are classified, and the different characteristics of the transition elements. So what is the prerequisite required for this lecture? You should know about the transition elements, how they are classified, why the D block elements are called transition elements, and the general characteristics of the D block elements, electronic configuration, oxidation state, the complex tendency, formation of the colored ions or the compounds, and catalytic activity. In this lecture, we should talk about two more general characteristics of the transition element, that is formation of the interstitial and non-stoichiometric compounds, and the metallic character and the alloy formation by the transition elements. So these two important characteristics we should talk in this lecture, as well as the properties of the transition elements and what are their periodic trends we should learn in this lecture. What is the learning outcome of this lecture? The students will be able to understand about all the general characteristics of the transition elements, as well as the properties along with the trends in the periodic table. So we have the two important characteristics of the D block elements, the formation of the interstitial and non-stoichiometric compounds. The D block elements form the interstitial compound. What are the interstitial compounds? These are the compound which is formed when an atom with a small radius just have the interstitial site or the hole in the metal lattice. So if we talk about, there is a solid lattice and the interstitial site in the lattice is between the atoms. The space is there, the gap is there between the atoms. If we are having this type of the lattice, it is go for attaching with the atoms. So we have the gap or the space between these atoms, which is called the interstitial site. And the D block elements generally combine with the non-metal atoms and accommodate these non-metals into these interstitial site. Okay, so with forming the defect in the lattice structure, and that is also called non-stoichiometric defect. We have read it, the solid defect, Schottky defect, Frankel defect. Even we have the non-stoichiometric defect like the metal excess, metal deficiency. Understood? So there you can see in the gap, the non-metal can easily come up. So D block elements form these compounds with the hydrogen, carbon, nitrogen, boron, silicon. Due to these, it having the striking property, exhibit the semiconductivity, fluorescence behavior, the heterogeneous catalyst. So due to these defects, non-stoichiometry, we have the various property to be observed in the transition elements, and we can use this in the application as a semiconductivity, the fluorescence, the heterogeneous catalyst. So this is again an important property of D block elements. Now if we see its metallic character and the alloy formation. What is an alloy? The alloy is a combination of the metal with the metal or a non-metal in a definite proportion. All the d block elements are the metals, good conductors of the heat and electricity, which we can say the property of malleability and ductility. And all are solids mostly except the mercury. Mercury is liquid in the transition element, which exists as a liquid at the ordinary temperature. So these metals can form the alloys with each other or with the non-metals due to almost similar sizes of the atoms. Thus, the atom of one metal can easily take up the position in the crystal lattice of the other. And the alloys are usually harder, having high melting point than the parent metals. You know, if we talk about the iron and the steel is an alloy of iron to carbon. The carbon addition is there. So steel is more harder than the iron and having the higher melting point. They are more resistant to the corrosion than their constituents. If we talk about the corrosion of the iron, it can easily corrode, but steel cannot be easily corrode. Understood? So, the transition metals can easily form the alloy of the similar sizes of the atoms, and they have a very good properties. They are more stronger, the strength wise, with the melting points, and even more resistant to the corrosion. So after all the characteristics we have seen of the D block elements, let's talk about the periodic properties and has some trend in the periodic table. The atomic radii, the ionic radii, melting point and the boiling points, ionization energy, reactivity, standard electrode potential, reducing property. These all are the important periodic properties of the d block elements, which vary and have a definite trend along each one of the series. How many series of the transition elements are there? There are 4 series in the transition elements: 3D, 4D, 5D and 6D. So if we talk about all the series in the periodic table, the atomic radii, ionic radii, melting points, boiling points, ionization energy, reactivity, reducing property can have a definite trend which can be easily understood. The melting point and the boiling point of the d block elements or the transition elements are very high, and it shows that they are held together by the strong forces between the atoms or intermolecular forces. The melting point and the boiling point have the highest value in the middle of the series. It is because these elements have the maximum number of the unpaired electrons, that is d electrons, and which is available for the bonding. So that's why in the middle, and they are having the maximum oxidation state also in the middle of the series, and that's why it is having the formation of the bond with that unpaired electron, and the melting point and the boiling point of these elements are very high. Understood? And the maximum oxidation state also, it is highest in the middle of the series. As in the first transition series, it is goes for the scandium to the first transition series starts from the scandium to the zinc, and the middle of the element which is having the highest oxidation state, that is manganese. Okay, so that is also we can understand with the oxidation state and with the maximum number of the unpaired d electrons which is available for the bonding, and it is the reason for the high melting point and the boiling point found in transition elements. Now if we talk about the ionization energy and the reactivity of the transition elements. What do you understand by the ionization energy? It is the energy released when the electron is added to an isolated gaseous atom. Understood? So that is ionization energy. The ionization energy value, if we see for the d block elements, are fairly very high and lie in between the s and p block elements. So if we compare the ionization energy of the d block elements and the s and p block elements, so we can see the d block elements ionization energy is fairly high, which can say it is lie between the S and P block elements. These elements are less electropositive than the S block elements. Which elements are highly electropositive? That is S block elements. They have the tendency to lose the electron, and that is called the electropositivity. Remember? And the P block elements, they are having the electropositive character more than the p block elements. From the s block, it is less electropositive and more than the p block elements. These elements do not form the ionic bonds or the compounds as it forms readily in the s block elements, and form the covalent bonds as well. Because of the existence of the covalent bonding, they have the high heat of sublimation, which we can say the large amount of the energy required to convert them from the solid state to the vapor state. The metal ions also do not get hydrated easily. Due to all these reasons or the parameters, the metal ions have a small tendency to react, if we say for the transition elements. Understood? Very high energy is required to convert from the solid to the vapor state, and it do not get hydrated easily. So from all these properties, we can say that they have the small tendency to react. as the highly reactive elements, and they generally form the ionic bond, that is S block elements. Okay, and P block, if we say they are highly electronegative, that's why they form the easily the bond. But if we talk about the reactivity of the transition elements, their reactivity is small. So small tendency for the reaction to take place for formation of the covalent bonds and the ionic bonds. Understood? Now if we see the periodic property standard electrode potential, that is the reduction potential and the reducing property of the transition elements. The standard reduction potential values of the transition elements are generally lower. Lower, that is, we can say negative. We should remember the electrochemical series we have read in the physical chemistry part. If you do not remember, just remind the electrochemical series, the arrangement of the reduction potential, the increasing order. When we put the elements according to the increasing order of the reduction potential. Okay. From the starting, we have the lower reduction potential, and then we move towards downwards, we have the higher reduction potential. And in the reference, it is always taken for the hydrogen, it is 0. Okay. So the lower reduction potential, that is to be taken as a negative. Remember, negative means the lower reduction potential, and above the 0 we have the higher reduction potential, that is observed by the positive sign. The lower reduction potential is observed by the negative sign. So the transition elements is having the lower electrode potential. Thus, they evolve the hydrogen gas from the acids. They have the ability to evolve out the hydrogen gas when they react with the acid. Though most of them do at this low rate, but they can evolve the hydrogen gas. So we can say these metals are the poor reducing agents, okay, which are contrary to the expected behavior because of the high heat of vaporization, high ionization energy, and low heat of hydration. So if we talk about the reducing property, you know what are the reducing agent which help out in the reduction and self oxidizes. Okay. So if we talk about its potential, it is of negative potential. That's why they are poor reducing agents. Understood? They are good oxidizing agents, you can say. Those who are having the negative potential, they are the strong oxidizing agent. Remember, the strongest oxidizing agent is lithium, which is having the lower reduction potential. Understood? So they are the poor reducing agents because of the high heat of the vaporization, high ionization energy, and the low heat of hydration. So you have seen all the periodic properties of the transition elements and how they vary in the periodic table. We should understand each one, that like the atomic radii, which is the distance between the two uh, distance between the two atoms, So they go for the atomic radii, ionic radii, melting point, boiling point, which is which is highest. We can say they have the intermediate properties between the S and the P block elements, and the ionization energy. So transition elements are having the high ionization energy because we can see it is having the less tendency to react. It is not strongly reactive power as the S and the P block elements. Including, we have seen the standard electrode potential, and if we talk about its reducing property, you can see here they are the poor reducing agents, and they have the capability to evolve the hydrogen gas from the acids. So these all are the periodic properties and its trend we have seen in the general series of the transition elements. Now we begin each one of the series individually. Okay, the first series we take first, and then we have the second and the third series in the unit 2. So after this completion of the periodic properties, we individually take the series. So what is the first series of the transition elements? That is 3D series, where it starts from scandium to zinc. Yes. So individually, all the properties, including the characteristics, okay, like the complex tendency, the formation of the colored ions. So in each one of these series, we talk in detailed manner. As all the properties generalized we have taken in this lecture, now we go in the detailed form in the series. Thank you and take care.